it's genetic. Some immune system is programmed to overreact. It's all about the training of the cells that are overreacting. The training is not as good as for other people. But here it's more publicized, I think, in America, and more taken care of than in other parts of the world, where people say, he's sneezing, he's not dying, he's fine. It's not allergy. But they have been, for example, allergies. They're mostly caused by immunoglobulins that are not IgGs, are the ones that the cells of the acquired immune system are releasing to destroy the antigens, and those are not and those are the good type of and kind of they're universal against bacteria, viruses, and helminths or larger eukaryotic pathogens. So what happens is that eukaryotic pathogens, that those are amoebas, helminths, those are flat worms, etc. They, the IgGs that are the immunoglobulin that's released by the B cells, they're not very efficient against killing them, because the function of those antibodies is to bind to the pathogen and then help the phagocytic cells to engulf and destroy it. But when the pathogen is bigger than the cell, our cells, we can't deal with it. So there is another type of response, and those are IgG, immunoglobulin. Is it E or M? E, thanks. So those are kind of bouquet of immunoglobulin G. They're big molecules. They're not intended for the phagocytic cells to bind them and engulf the pathogen and destroy it inside, but they're meant to bind the pathogen, and then it gets decorated by them, and then the cells that are not very highly trained soldiers of the acquired immune system, those are the cells of the innate immune response, when neutrophils and other white blood cells that are releasing histamines to activate the cells to secrete enzymes that destroy. So they're meant to destroy the big pathogens outside of the cells, because they cannot phagocytose. So when you have other infections like worms, you will cure yourself temporarily of the allergies, because they distract the attention of the immune system. So those are the antibodies that are meant to destroy big pathogens. So when you have this pathogen, they're attacking it, and they are not kind of overstimulating the immune system. But when we don't have them, which is also the theory of the hygiene that we have here, then people start developing. But there are multiple mechanisms for allergy development or autoimmune disease. So I won't even go there because I'm not expert. You can talk to the expert for free.
The enzyme that you are targeting against, I think that enzyme is essential for harmful bacteria, right?
For all kind of bacteria, not just, you cannot discriminate between harmful and not harmful. That's why we're getting antibiotics nowadays. They're also killing our good bacteria in the intestines. We were also interested in developing like antibiotics against particular class of bacteria. The problem is that those will rarely see the big world. They will not get out of the research bench, because it's very expensive. Unless it's expensive to develop drugs against particular bacteria, because when you go to the doctor's office, the doctor doesn't know what kind of bacteria causes the disease. Unless there is a good system of screening and then assigning the drug. And probably they can be developed against several known pathogens that are very persistent in the population, but it's still in the infancy. But this type of design is based on sequence of RNA. It's also the same enzyme because it recognizes particular sequence. If you block it, it can't work. But the problem is the delivery has to be very efficient. We're also working on delivery. Yeah, just it's good for publication, but will it reach to the doctor's office? It's a big question.
So it's taken 70 years to get a quick test for strep throat. What is the research for getting quick tests for other bacteria?
So those that are, so nowadays you can develop tests for 1 year. It depends who will take over and make it industrial. I mean, who produce the test, in how much, in what amount to sell it, because it's all profit. And that's why also the Department of Threat Reduction is interested in detecting infection without being specific what kind of infection, like bacterial or virus, and is it a pathogen, because those that are not pathogens, our immune system will not react in a certain way. If they're pathogens, immune system will react. So now the tests, the interest, it's still in infancy, it's still on the research bench, is to find markers that our body releases, and they're consistent from person to person, because we also differ genetically, but they're markers that are there in all of us, to find them and also to make them specific, so the doctor can say, do a test, like the strep test, and say, okay, you have bacterial infection and it's a pathogen because your immune system is reacting, or it's a virus. But those tests are just to tell you that you have some kind of infection, not what exactly. Because they are emerging disease that people cannot develop tests for all of them. But at least this kind of tests will tell you if you need antibiotics that are bacterial, antibacterial. But it's still in the beginning, like the research phase. Such markers are not known yet. Oh, good.
So what is your opinion on like quorum sensing inhibitors for like research into that?
Yes, people are also researching it and investing. So quorum sensing is bacteria usually when they're under stress, they send signals, chemical signals, and one of those signals that are small molecules, some of them trigger this chain of reactions in bacteria when they start secreting sticky, gluey material that sticks them together and they form biofilm. Then no antibiotic can go through this biofilm, and that's another mechanism of resisting the antibiotics that is not genetically determined. It's because of barriers that bacteria. So there is research. People are also trying to figure out if they can intercept this communication by drugs or antibodies, mostly antibodies. So bacteria cannot communicate. That is, antibodies are expensive. And they lose their potency over time because our immune system develops reaction against those antibodies to clear them out. Because they're not produced by us. So I don't see how this kind of treatment will be persistent like the way of small molecules drugs, unless somebody finds a small molecule that doesn't develop immune response, that also intercepts this communication. But people are working. I mean, there is so much different like branches of research in the fight against bacteria. But bacteria is still kind of winning because they are very communal. They work together, and they multiply very fast. And then also they tolerate mutations that keep them alive, at the same time makes them resistant to treatment.
So I've got a question. So imagine a scenario where you've got a lot of bacteria in your body you really don't want, and you have a really effective antibiotic. It kills all of those bacterial cells. Would your body, maybe you can't answer this, but could your body be overwhelmed by trying to get all of these dead bacterial cells out of your body?
Oh, if you have so much, you'll be dead before.
Well, I won't worry about that.
Yeah, if you'll be like dead before the treatment starts. Usually, so much bacteria that will clutter the like kidneys. Yeah, our kidneys are definitely under stress during infections. And it's not just the bacteria, but all the complexes the immune system forms to clear the bacteria. And also the drugs will take to kill. And that's why it's good to drink lots of water. Wine a little bit when you're sick. Probably it's good as prophylactics. But lots of fruit, like black fruits, they have tannins as well without the alcohol part. So they help. And people have found that tannins can help also the balance of the good bacteria over bad in our intestines. So our immune system is highly dependent on the health of the microbial populations in our guts. That's why there is entire new discoveries that people try to figure out what is the right proportion of bacteria so they can make pill, like probiotics, so we can get it during, especially after antibiotic treatment, but as prophylactics. Here and there you can find some super bacteria that they add to probiotics, but it's just one type. But yes, I mean, we have to just be well hydrated, but we can never reach this level of such a high load of bacteria or even viruses in our body that we cannot clear, because before that our immune system will be going crazy and killing us.
What's your opinion of triclosan, the antibiotic they stick in hand soaps? Should we not be using that?
I mean, it kills the good bacteria that protects us. And
yeah, so soap kills bacteria anyway.
It doesn't, it just makes it more loose so it can get washed away. Soap actually doesn't have antibacterial action. Even triclosan is not very effective against all kinds of bacteria. And I don't know, but people, even during the flu epidemics, probably not triclosan, but the alcohol rubs, they're more efficient just to kill or make them less potent, viruses mostly, than bacteria. But yeah, it could help, for example, in hospital settings when nurses and doctors are exposed to pathogenic bacteria to reduce their load. But it has been shown that they're very resistant to such cleaning agents in the concentration that our body can tolerate. If you use it in the concentration that they wipe the floor, probably it will be good, but so yeah, it's not good to overdo it like in your homes, in hospitals, and it's good for hospital workers to use gloves if they can change gloves more often than wash so often.
Are these the bacteria getting more resistant to like the bleaches and stuff to make it harder to sterilize hospitals as well?
So there is no like resistance to bleach 100%, but bleach is like one of those offenders. Those are type of so they're oxidizing agents. and they put bacteria into like a stress, and it starts reducing these antioxidizing enzymes and all kind of enzymes of the SOS system. So those are also destroying the antibiotics. But in the concentration that bleach is used to wipe the surfaces, very few bacteria can survive it. So if it's not used in the right concentration, it can just stimulate them to become more resistant. But higher concentration, very few bacteria survive.
So follow-up question, what is the right percentage? If I want to do a bleach, solution to disinfect my counters, what's the right amount?
I wouldn't, I don't know. We tested this in this class of microbiology class that I taught. So if you dilute it and make 10% of what is in the container that comes from the hospital, not hospital, the stores, it will kill within 15 minutes most of the bacteria.
So spray it on and
10%.
leave it for 15 minutes?
Yes.
Okay.
If you wipe it immediately, it won't kill them all. But there could be some, like spores, some bacteria, these gram-positive bacteria can form spores. You cannot kill them with bleach at all. And if the concentration is not right, it can stimulate spore formation, or in the bacteria that doesn't form spores, it stimulates the resistance to antibiotics. So yeah, the right concentration is usually 10%, but if you don't dilute it, especially in the toilet bowl, don't dilute it, it works even better.
So the problem with spraying the countertop with Clorox spray is that in the winter, the humidity is so low, it evaporates before 15 minutes.
Right.
So what do we do?
Especially in New Mexico, I don't know.
Low humidity also contributes to lower levels of bacteria.
Or viable bacteria. It just gets into dormancy. You just have a healthy diet so your immune system be stronger.
Drink lots of wine.
And water, of course. But there was this movie that I can't forget. It was French movie. The translation, I was still in Bulgaria. It was Hussar on the Roof. I don't know if it was ever shown here, but that was during the plague.
That was a horseman on the roof.
Yes, yeah.
That's a good movie.
Great movie.
Yeah, so there was a love story, of course, but it was during this plague epidemics, and the heroine, she contracted the plague, but the strongest symptoms showed when they were away from Paris. They entered an empty house with a cellar of wine. So what he did, he was giving her wine and he was rubbing her with wine. And she survived. And I said, okay, alcohol has some effect, and tannins, good combination. But I don't know, nobody has tasted it on real life, it's just fiction. And of course, alcohol, if it's too much, it decreases the immune system's function. So everything is in good balance, like when you have.
So on that note, let's thank our speaker for tonight for coming.